Hey guys, welcome to my next video, which is graphs of f, f prime, and f double prime. I want you guys to go ahead and put a star next to this title. This is exactly what you'll be seeing on the AP exam. Now, let's go ahead and begin with our first problem. The graph of f prime is given above. The domain of f is from -3 to 3 inclusive. So, what graph did they just say they gave you? They gave you f prime. So already you guys should already be doing this. Okay? This is the graph of f prime, not f. The domain of f is from -3 to 3. Well, the domain of the f prime is from -3 to 3, so that means that the function is continuous and it's differentiable because the derivative exists because we have it right in front of ourselves. Okay? Let's do some pre-work here. Okay? When I like to do pre-work, I like to draw a line right here. If this is f prime, then everything above f prime is considered positive. So I'm going to use yellow for positive. That's positive. That's positive. And that's positive. Notice that 2 is not positive because 2 is actually 0. Okay? So let me go ahead and use another color for negative. I have negative here, and that's it. Okay? So let's do some pre-work. What does it mean for a derivative to be positive? That means that the function is increasing. Okay? So let's write some notes. F is increasing on what interval? Well, where is where is the derivative positive? On -3 to -2. Is that the only place that it's increasing? No, it's also increasing here, here, and here. So from 0 to 2 and 2 to 3. Now we're not using infinity or negative infinity because if you notice, f has a domain. It doesn't go to infinity or negative infinity. -3 and +3 are the endpoints of this graph. Where is the graph decreasing? The graph is decreasing only on the blue highlighted part. So it's negative here, negative there also. Okay, so it's decreasing on -2 to 0. Now, what else can we deduce from this graph? Look at this. The derivative goes from positive to negative, and then from negative to positive. What does it mean for a derivative to go from negative to positive? That means that you have a maximum. So this is a max. This is a min because you're going from negative to positive. So f has max at x is equal to -2, and f has a min at x is equal to 0. Now let's take a look at x is equal to +2. Does the graph switch signs? Well, no, it doesn't switch signs because it's going from positive to positive. So the derivative is still positive on both sides of 2. So that means that 2 is not a maximum or a minimum. It's got to switch signs. Okay, so before I start going any more further, let's go ahead and just do problems A and B, and let's see what we can deduce from those problems. So for what x values from -3 to 3 is the graph increasing? Justify your answer. Well, we already answered that. F is increasing on those 3 intervals. So we're going to write a sentence. F is increasing on -3 to -2, 0 to 2, and 2 to 3. Because, well, what did we just say? Why is it increasing? Because f prime of x is positive. That's all the reason you have to give. You have to give reasoning from what you're given. Okay, you have to use the evidence that you're given on the table. You can't go to another room and pick out evidence. You can't say because it is increasing. Well, what makes it increasing? Because the derivative is positive on these three intervals. Letter B. For what values of x from -3 to 3 does the graph of f have a relative maximum? Well, we already know what the answer to that is. So let's go ahead and write our sentence. F has a relative max at x is equal to -2 because, now we have to use calculus to explain our reasoning. Why does it have a relative max? Because f prime changes from positive to negative. And that's all you have to say. For what values of the graph from -3 to 3 is the graph concave down? Justify your answer. Okay, so apparently we don't need to answer minimum or decreasing here, but it didn't hurt for us to figure that out. But let's go ahead and analyze concavity. Okay, what does it mean for a graph to be concave up? So f concave up when f double prime is greater than 0, or another way to explain this, or is when f prime is actually increasing, not positive. It's different. Okay, if the derivative is positive, that means f is increasing, but if the derivative is increasing, that means that f double prime is positive, as you just saw what I just wrote there. F is concave down if f double prime is negative or f prime is decreasing. So I'm going to go ahead and for myself, I'm going to go ahead and erase these highlighted parts, and I'm going to go ahead and use green to determine where is my derivative increasing. So I'm going to start with -1 because from -3 to -1, it's my derivative is decreased, it's going down. From -1 to about 1, it's increasing, and then it's also increasing from 2 to 3. In purple, this is my decreasing. So let's go ahead and see what the question says. It says here, for what values of x from -3 to 3 is the graph of f concave down? Well, concave down means first derivative decreasing. So let's go ahead and see. The derivative is decreasing from -3 to -1 and from 1 to 2. F prime, I'm sorry, no, I'm on the wrong problem. F is CC down on -2 to -1. Let me just check to make sure. -2, no, I'm sorry, no, -3 to -1. And 1 to 2. Because F prime is decreasing. And that's all you got right. Now let's go ahead and take a look at part D. For what values of x from -3 to 3 does the graph of f have a point of inflection? Have an inflection point? Well, an inflection point occurs is when the second derivative changes sign. So when the second derivative changes sign means when the derivative goes from positive to negative, or vice versa, or when the graphs of f prime go from increasing to decreasing, or from decreasing to increasing. Now, how many times do you see the graph of f prime changing from decreasing to increasing or increasing to decreasing? I see 1, 2, 3 times. I see 3 points of inflection, -1, 1, and 2. F has inflection points, at x is equal to -1, 1, and 2, because now you can't say because the second derivative changes sign, because you're not given a second derivative graph. You have to use the evidence given to you. So because f prime changes from increasing to decreasing and decreasing to increasing. So this is a good way to explain both cases like this. Rather than trying to explain each individual point, you can just say it changes from increasing to decreasing or decreasing to increasing at these points. And that'll be it for this lesson. So I'll leave you guys with part E on your own. It says here, use the information found above and the fact that f of negative 3 is equal to 0 to sketch a possible graph of f. So that is actually too many answers to discuss there. There are so many ways you can do this. I'll leave you guys that as an exercise. So that's it for today.